All right, here are solutions to perfect problem 6 for Math 211. You're doing a bunch of operations, but in binary, everything's base 2, which is, I don't know, either fun or obnoxious, depending on your point of view. But regardless, this first problem here, you're asked to subtract these two numbers. However, you're told to do it using the standard algorithm. That's also known as the intermediate algorithm. So what we're doing here in 1 is we're taking this first number, which is 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1. And from that we are subtracting 1, 1, 1, 0, 1, 0, 0, 0, 1, 1. Okay, and the basic idea here is we'll do it just like, I don't know, your normal algorithm, but you have to be a little bit careful when you borrow from another column. So we'll see what happens when that happens. I'm going to start from the right here and work my way to the left. 1 minus 1 is still 0. It's not any different just because I'm in base 2 here. So I'll put a 0 here. But here's where things start to get a little bit weird. I want to do 0 minus 1. Well, you can't take away 1 from 0, so I'll have to borrow. Okay, that's fine. From this 1, I borrow, which makes it a 0. But that makes this a 2. You might have thought that it would make it a 10, but since we're in base 2, anytime you borrow from a neighbor to the left, you're getting 2, not 10. Now this is a 2, or 1, 0, if you want to think about it in base 10, we can subtract. And 2 minus 1 is just 1. And now that this is a 0 here, 0 minus 0 is just 0. And so the subtraction continues. 1 minus 0 is just 1. 0 minus 0 is 0. And then here's where things get weird again. So I'm trying to take away 1 from 0. I can't. I don't have any. I have to borrow. Well, I want to go over here to borrow, but I can't borrow from here because there's nothing here either. So I'm going to go all the way over here. I'm going to borrow from this. So instead of being 1, it's now 0, which changes this from instead of 0, it's 2. And now that this is 2, I can borrow from this 2 to fix this 0 here so I can do my subtraction. So I'll cross out this 2 and move that down to a 1 and bump this 0 up to a 2. And now I'll go through and subtract. 2 minus 1 is just 1. 1 minus 0 is 1. 0 minus 1, oh, that's a problem again. So I want to borrow, can't borrow from here because I don't have anything. So I'll go all the way out here, make that a 0, which makes this a 2. And now that this is a 2, I can borrow from it, which makes it a 1 and makes its neighbor a 2. And now I go and subtract again. 2 minus 1 is just 1. 1 minus 1 is 0. I'm almost done here. I want to take away this last 1 here. I don't have anything. I got a 0 here. Better borrow from that guy. Makes that a 0, makes that a 2. 2 minus 1 is just 1. So my answer would be this weird number right here. Okay, number 2. Subtract again. Why are you subtracting again? You got me dividing on one of them, multiplying on one of them. Why am I subtracting twice? I feel like I should be adding once here to get practice with all the algorithms. Well, that's true. However, when you subtract using the 9's complement method, although I probably shouldn't call it the 9's complement anymore because we're not in base 10, essentially you end up adding. You change a subtraction problem into an addition problem. So really my purpose in 2 here is to get you practice with addition. So we're going to try to subtract these two numbers, and the way we're going to do it is we're going to write the first number 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1. And instead of making it minus, maybe I'll write that first, minus 1, 1, 1, 0, 1, 0, 0, 0, 1, 1. I'm going to change this problem into another problem. I'm going to change this into an addition problem by keeping this first number the same, but changing this number. And the way I'm going to change it will be similar to what I did when I did the 9's complement, but it was the 9's complement in base 10. So now that I'm in base 2, it would really be the 1's complement. Well, the 1's complement, anywhere I see a 1, I'm just going to change it into a 0. Anywhere I see a 0, I'm going to change it into a 1. So instead of subtracting this, I'm going to add. And everywhere I see a 1, like right there, I'm going to change it into a 0. I got another 1 right there, another 1 right there. I got a 0, so I'll change it into a 1. I got a 1, I'll change it into a 0. Change those zeros into 1s. I'm going to do this addition problem right here. Now when I go through and add, 1 and 0 is 1, 0 and 0 is 0, 1 and 1 is 2, which in base 10 is 0 singles and 1 group of 2. 1 plus 1 plus 1 is 3, which in base 10 is 1 single and 1 more group of 2. 1 and 1 is 2, which is 0 singles and 1 group of 2. 1, 0, and 0 is just 1. 0 and 1 is 1. 1 and 0 is 1. 0 and 0 is 0. 1 and 0 is 1. And 1 and 0 is 1. So I get this weird answer right here. However, this answer is not the answer to this question. So why'd you bother doing all that work? Well, it's predictably wrong. In other words, if I would just take this leading digit here, this 1, and add it over to this number, what I would get would be the answer over here. So let's see what I would get. This is no longer here, so I have 1, 0, 1. I guess 1. Sorry, let me space these out a little bit better. Maybe I should put commas in here. Maybe that would help. I got 1, and then I got 0, 1, 1, and then I got 1, 0, 1. But then this last little group, I got 0, 0, 1 plus 1. Well, 1 plus 1 is 2, which in base 10 I write as 0 and then carry a 1. So what I'm saying is that using the ones complement method, I guess, I would get that this is this, which is the answer up here. And I can check my answer. 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0. Awesome. Looks like that checks out. All right, moving on. Multiplication, specifically multiplication with the lattice method. All right. So pretty large numbers to be doing this with, but I guess if you have to do it, I should have to do it too. 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1 is one of the two factors, one of the two numbers I'm multiplying together. I want to multiply that by 1, 0, 0, 0, 1, 1. That gives me this big grid right here. I'm going to pause it while I make the grid so you don't have to watch me make the grid. All right, now that I have my big grid here, I can start doing my multiplication. So the basic idea is inside this green grid, I'm going to multiply each of the numbers. So like in this spot, it'll be this 0 times this 0. However, any two-digit number, I can write the tens digit or twos digit in this case up here and the ones digit down here. That's a little bit strange in binary because in binary I'm just multiplying ones and zeros or ones and ones or zeros and zeros, which is always either 0 or 1. So I can kind of go through here quick and do it. 1 times anything. 1 times 1 is just 1. So there's 1. 1 times 0 is 0. There's 0. 1 times 1 is 1. 1 times 1 is 1. 0, 0, 0, and so on. 1, 0, 1, 1. 0 times anything is 0. What that means is this entire row is just going to be zeros. And actually, the next couple rows are going to be zeros because these are all zeros right here. Last two rows, it's 1 times something. So 1 times 1 again is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 0 is again 0. And finally, 1 times 1 is 1. So I fill out my grid to look something like this. Wow. Okay, and now the last step here is I'm going to add along the diagonals. So these diagonal red lines are what I want to add. This is easy. 1 is just 1. 1 plus 0 plus 0, that's just 1. 0 plus 0 plus 0 plus 0 plus 1, that's just 1. Wait a minute, here it gets harder. 0, 0, 0, 0, 1, 0, 1, that's 2. But I can't write 2 in base 2. 2 in base 2 is 0 with a 1 carried. So I'm going to carry 1, I don't know, up here. Now I got 1, 2. So again, that's 0 with a 1 carried up here. 1, 2, 0 with a 1 carried. 1 is all, so I get this 1 here. 1, 2. So that's 0 with a 1 carried up to this diagonal. 1, 2, 3. Okay, you got to be a little careful here. 3 in base 2 is 1 single and 1 group of 2. So I'll carry 1. 1, 2 is 0 with 1 group of 2. 1, 2, 3 is 1 single with 1 group of 2. 1, 2 is 0 with one group of 2. 1, 2 is 0 with one group of 2. 1, 1, 1. So my answer is, I guess it ends in 1, 1, 1 for these 3 digits, and then has before that 0, 0, 0. And then before that has 1, 0, 1. That was these 3 digits. And then before that has 0, 1, 0. And then before that has 1, 1, 0. And before that has a 1. Wow. Okay, what a mess. That's what I get when I multiply these two things together. I'm almost done here. The last problem says divide your answer to part 3. That mess that I just wrote, divide that by this number using the scaffold method. Okay, 4. This is my answer to 3 is down here. And rather than rewrite that, I'm going to use that in part 4 down here where I use the scaffold method. And so I want to divide this number by 100,011. Divide this by 100,011. So I got to think about how many of these can go into this number. Well, let's see. I could get, if I tack on this number right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. And this number is 6 digits right here. So I could take away 1, 0, 0, 0, 1, 1. That's this number right here written underneath this number right here. And then add on a bunch of zeros. How many zeros? 1, 2, 5, 8, 11. So with 11 more zeros here. And what that just gave me is a 1 with, what did I say, 11 zeros? That's this many of this right here. And I can subtract. Oh man, subtracting these. Okay, well at least I got a lot of zeros at the end. So that'll get 1, 1, 1, 0, 0, 0, 1, 0, 1. And then I guess I got to be a little bit careful here. Whoops, getting my commas to line up. Okay, so now for the lattice method, I kind of want to subtract out chunks of some multiple of this number from this number. So how many can you subtract out? Well, if I write this number, 1, 0, 0, 0, 1, 1, right below this number in red, and then fill in a whole bunch of zeros, the number in blue will be smaller than the number in red, so I can't subtract it. How many zeros am I going to fill in? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I just multiplied this number by a 1 with 10 zeros after it. And so I'm taking away this number of these. And so now I got to subtract the two of these, which might seem horrible, but it's not as bad as you'd think because I got so many zeros at the end. Taking away 0, I can start filling in some of these guys. Let's see over here, 0 minus 0 is 0, 1 minus 1 is 0. 0 minus 1 is a little bit hard to do. I need to borrow from this guy, which would make this a 2. And now I can borrow from this guy, which would make this a 1 and this a 2. And 2 minus 1 is just 1. Maybe I should write that in a different color, I guess. So I could make this... No, I don't want to mess it up because then you wouldn't be able to see the answer to 3. So I'm just going to write the answer. I changed this into a 2, which I borrowed from, so there's really 1. And if I take away 0, I still have 1. I changed this into a 0 because I borrowed from it. 0 minus 0 is just 0. And now I'm all square again. 1 minus 0 is 1, and 1 minus 1 is 0. So I don't even have to write it. So now I have this number, and I want to take away some amount from this. Well, I can again, if I take this number, 1, 0, 0, 0, 1, 1, and tack on 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. The number in blue is smaller than the number in red. So I can take away this many of this thing. Subtract again. Okay, let's see. Subtracting with all the zeros, that part's pretty easy. It's going to leave me with this same thing. But here the subtraction is a little bit tougher. 0 minus 1, I can't do it. I have to borrow. Nothing here to borrow from, so I borrow from this. That changes this into a 2, which I borrow from, makes it a 1, makes this a 2. So this is a 1, this is a 0, this is a 0. And then here, 1 minus 0, those go away, those go away. I have this number right here. What can I get rid of now? Well, note if you write this number, 1, 0, 0, 0, 1, 1, and a bunch of zeros, the number in blue will again be smaller than the number in red. So I'm going to take this number right here in blue, 1, well I guess I should write it in blue, 1, 0, 0, 0, 1, 1, and then tack on zeros. How many zeros? Well, it looks like I'm tacking on 7 zeros. Tacking on 7 zeros, that means I got this many of these 1, 0, 0, 0, 1, 1 things. So I'm going to subtract again. And when I go to subtract, let's see, the subtracting by zeros part is pretty easy. 1 minus 0 is 1. 0 minus 1, I can't do it. I have to borrow. That changes this into a 0. 2 minus 1 is 1. If this is a 0, I can't do it, so I have to borrow from this guy. That makes this a 2. 2 minus 1 is just 1. This is now a 0. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 1 is 0. I only have this many left over. I'm getting there, slowly but surely. So let's take out another chunk. I'm going to take this number 1, 0, 0, 0, 1, 1, and get rid of some, tack on 3 extra zeros here before I subtract. The number in blue is smaller than the number in red. I have 1, 0, 0, 0 of these things written right here. I'm going to subtract. Subtracting by zeros here is pretty straightforward. I get 1, 1, 1. Now I want to subtract 0 minus 1. I can't do it, so I have to borrow all the way over here. That makes this a 2, which I borrow from, makes it a 1. This is a 2, I borrow from, makes it a 1, makes this a 2. 2 minus 1 is just 1. The 1 that this now is, minus 1, is just 0. The 1 that this is, minus 0, is 1. And then this is a 0. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. I have this many left. Repeat. Take this number, 1, 0, 0, 0, 1, 1. Tack on a couple of zeros. That means I have this many of these things here. And subtract them. This might be the last time I have to do it. Okay. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. 0, 0. I have this many left. Hey, look, that's exactly this number. Nice. I can take one of these, blue, I guess, if I'm really worried about color coding this. And if I write one of them, it's this number. And when I subtract here, I get 0. What that means is that this big number in red divided by this number in blue is equal to all of this stuff. If you sum up all this stuff, maybe I'll write it over here. I got a 1 from this one. I got another 1 from this one, comma, a 0 and then a 1, 0, comma, 0, 0, 1 for this guy, and then 1, 0, 1. I'm saying that this big number in red divided by this number in blue is equal to this number in green right here. The significance of that is I can go up here. Remember, up here I multiplied together this number in blue, that's written right here, and this big number up here to get as my answer this number in red. Well, note that the thing written up here, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 0, 1. This times this equals this, just like this divided by this equals this. Whew! Finally done with that. I'll end this video here.